Hi, everyone. In this lesson, we are going to discover the distance formula and use it to calculate the distance of a line segment in the coordinate plane. In other words, the distance between any 2 points in the coordinate plane. So first, we're asked to find the distance of a horizontal segment. Here are the endpoints. Since it's a horizontal segment, we can just measure it along the x-axis. We see it's 4 units long. Next, we have a vertical segment that we can measure along the y-axis. We see that this segment is 6 units long. Now we have a segment that is neither vertical nor horizontal. So if we look at the endpoints here, we can tell that this segment is longer than 2, but less than 3. But it's hard to tell exactly how long it is because we can't measure it along the y-axis or along the x-axis. So for now, we can say between 2 and 3. If you wanted to estimate further and say 2.1, 2.2, that would be okay. But it's all right for now to say between 2 and 3. By the end of this lesson, you will be able to exactly calculate the length of this segment. So now we're going to talk about using the Pythagorean theorem to calculate the length of the segment on the left. Recall the Pythagorean theorem is a squared plus b squared equals c squared. So solving for c gives us c equals the square root of a squared plus b squared. We don't have a right triangle, but we can draw a right triangle. So we're going to select the segment tool and we'll draw a vertical segment. And a horizontal segment. And this is a right triangle. So we see that the vertical segment has a length of 1. The horizontal segment has a length of 2. So we can use the Pythagorean theorem to solve for the hypotenuse length. We know that c squared is equal to 1 squared plus 2 squared. And solving for c gives us c is equal to the square root of 1 squared plus 2 squared, which is the square root of 5, around 2.2. And we can just say that work is shown in sketch. So now we want to determine the length of this segment using the Pythagorean theorem. So first I draw a triangle. And then I label the lengths of the horizontal and vertical segments here. So the vertical segment has a length of 4. And the horizontal segment has a length of 10. And using the Pythagorean theorem, I get that c squared equals 10 squared plus 4 squared, which is equal to 116. So that means that c is equal to the square root of 116. When we type squaring a variable, we just need to use Shift 6 and then type 2. That will give you the caret, which allows you to type exponents. And then to type a square root symbol, it's SQRT. And sometimes you'll need to select the math box and type that out. Okay, now we just need to figure out, is there a way that we can simplify the square root of 116? Well, the square root of 116 is the square root of 4 multiplied by the square root of, now let's think about this. What do we multiply 4 by to get 116? That is 29, right? 29 multiplied by 4 is 116. So this simplifies to 2 square root 29. So the length of the hypotenuse here is 2 root 29. And you could also express that as a decimal by calculating. If you put 2 root 29 into Desmo Scientific Calculator, it'll tell you what that is to the nearest tenths place. And we can say work shown in diagram. Okay, next. So we can determine the length of this segment using the Pythagorean theorem. So let's draw the side lengths of this triangle. Okay, so the vertical segment has a length of 1, and the horizontal segment has a length of 9. So now we use the Pythagorean theorem to calculate the hypotenuse. So we know that c squared equals 1 squared plus 9 squared. And that is 82. So we get c equals the square root of 82, which is 2 multiplied by 41. We're not able to simplify that anymore. So we could leave it like the square root of 82, or we could calculate the decimal by plugging that into a calculator. We know that it would be between 9 and 10. So the length between these 2 points is the square root of 82. The distance between these 2 points is the square root of 82. Great. Okay, so notice that when we draw this triangle, the length of the horizontal leg is 3 minus -2, which is 5. And the length of the vertical leg is equal to 0 minus -5, which is 5. So we can subtract the coordinates to find the side lengths of this triangle, and this gives us 5 and 5 for both. So for this reason, we don't have to have the triangle sketched out for us. We can subtract the x coordinates to get the horizontal distance between the 2 points, and we can subtract the y coordinates to get the vertical distance between the 2 points. And then we use the Pythagorean theorem in the same way to find the distance between these two endpoints, -2, 0, and 3, -5. So this brings us to the distance formula. The distance formula is the distance between 2 points is equal to the square root of x2 minus x1 squared. So in other words, the difference between the x coordinates plus the difference between the y coordinates squared. So in other words, if we find the horizontal distance and the vertical distance between the 2 points, we square those numbers, add them up, and take the square root. So it is possible to do this by assigning x1, y1, x2, y2 to -2, 0, and 3, -5. But we don't have to do this. Often students find when they assign x1, y1, x2, y2 to the coordinates, they can get confused and forget what they're doing as they're performing the calculation. So there's a way that we can do this problem that involves creating a table and simply calculating the horizontal distance, calculating the vertical distance, and plugging it into this formula. Okay, so we want to calculate the distance between these 2 points. We have -2, 3 and -7, -7. So we make a table. And we put both of our points in the table. So we have -2, 3, -7, -7. So now what we want to do is find the horizontal distance between these 2 points. Well, we know that -2 and -7 are 5 apart on the number line. And then we want to find the vertical distance between these 2 points. So think about how far apart 3 is from -7. That's 10 apart on the number line. So then we're just going to plug these numbers in to our formula. x2 minus x1 is the horizontal distance between the 2 points, 5. y2 minus y1 is the vertical distance between the 2 points, 10. So we're going to write d equals the square root of 5 squared plus 10 squared. And this gives us the square root of 125, which equals the square root of 25 multiplied by the square root of 6, which is 5 root 6. Let's do another example together. So now we have the points 2, -9 and -1, 4. So we start by making a table. And we write in the numbers 2, -9, -1, 4. Great. So now we just need to find the vertical distance and the horizontal distance between the 2 points. The horizontal distance between the 2 points is going to be the distance from 2 to -1. Well, that's just 3 away, right? And the vertical distance between the 2 points is the distance from 4 to -9. So that's 13 away, right? So we have a horizontal distance of 3, a vertical distance of 13. So x2 minus x1 is 3, y2 minus y1 is 13. So that equals 13.3 to the nearest tenths place. It's fine to leave your answer this way and allow this to calculate it for you. We can leave it just like this. If we were to go forward, it would be the square root of 9 plus 169. Which is equal to the square root of 178. And to the nearest to the nearest tens place, that's 13.3. Okay, let's keep going. So for example 7, what I'd like you to do is pause the video, try to make this table. If this is not working so well for you, showing your work here, you can do it on paper and take a picture and upload that with your work. That would be fine. But do try to make this table if it's not too much trouble with your trackpad. So I'm going to set this up for you and then make sure that you pause the video and try to find the horizontal distance and the vertical distance between these 2 points and then plug it into the distance formula. And I'm going to pause for a moment. Okay, so hopefully you pause the video to see how you did. 8, 5 goes here in the table, -1, 3 goes here. And now we simply want to know what's the horizontal distance and what's the vertical distance between these 2 points. So these 2 points are 9 apart horizontally and they're 2 apart vertically. So that means that the distance equals the square root of 9 squared plus 2 squared, which is 9.2 to the nearest tenths place. And if we were to write this out, this would be the square root of 85, which is approximately 9.2. Okay, again, I would like you to pause the video and check your understanding by creating a table, finding the horizontal distance, the vertical distance, and then plugging those numbers into the formula. So hopefully you pause the video to check. Now I'm going to go through it. So here's -6, -10, -2, -10. Oh, well, we notice that this is pretty easy because both of the y coordinates here are -10. So the distance between the y coordinates or the vertical distance is just 0. And the distance between the x coordinates is 4. So these points are 4 apart. But if we were to use the distance formula just to see how it works in exactly the same way. It would be 4 squared plus 0 squared, which is equal to the square root of 16, which is 4. But it would be totally fine to just use the horizontal distance between these 2 points, because the horizontal distance between these 2 points is equal to the distance between the 2 points, since the vertical distance between the 2 points is 0. So this is your assessment question. Please show work. If you do not want to show work using the sketch tool, you can show your work on a piece of paper, take a picture, and upload that to Classroom. Also, once you select your answer choice, you can explain your work in the box that pops up here. So please do that. And then I would like you to tell me any questions you have after completing this activity, and tell me about any feedback you have to share. Thank you very much. Have a good day.